I want you to really put yourself in the cockpit for a second. We're going to start work.
The kind of environment that keeps military planners awake at night.
Oh, absolutely. Below you, just dispersed across the terrain, you've got these advanced surface-to-air missile batteries, and they are all tightly linked to early warning radars.
And it's not just the ground threats. Ahead of you, there are enemy combat air patrols.
Yeah, fourth-generation fighters. They are sweeping the airspace, actively radiating, just, looking for a target. Now, in a legacy aircraft, surviving that kind of a mission of today's deep dive is to unpack exactly why the F-35 Lightning II is widely considered one of the most dangerous, most advanced fighter jets ever built.
And how it's fundamentally changing the way modern air combat works.
Because when we look at the source material, the operational data, the tactical doctrines surrounding this jet, it all points to a massive paradigm shift.
What's fascinating here is that the narrative has moved completely away from traditional metrics.
Like aerodynamic performance.
Exactly. Air combat is no longer strictly governed by kinematic superiority.
Right, it's not about who has the highest top speed anymore.
Or the tightest turn radius. Or even the highest thrust-to-weight ratio. The true metric of lethality now, the overarching theme of all our sources today, is information dominance.
Information dominance. It's a huge shift, and the sources emphasize that heavily. The engineering focus for the F-35 prioritized the ability to gather, process, and control the flow of information across the battle space.
All while actively denying the adversary that exact same capability.
But to achieve that level of information dominance, especially in the contested environment we just talked about, the platform actually has to survive first.
Which brings us to the very foundation of the F-35.
It's low observable technology.
The stealth.
Right, stealth. And the literature we're looking at is very, very clear that the F-35 represents a ground-up stealth design.
Which is fundamentally different from older approaches.
Yeah, it's not like taking a legacy airframe like an F-15 or an F-16 and just slapping some radar-absorbent materials on it to reduce its cross-section.
The distinction there between a platform engineered with low observability as a foundational, non-negotiable requirement versus one that has it applied retroactively, it is massive.
Because true stealth dictates the entire geometry of the aircraft.
Right, completely. When we look at the physical characteristics outlined in the technical sources, the absolute primary factor in defeating radar is edge alignment and continuous curvature.
Continuous curvature. Break that down for us, because older stealth designs didn't look like that at all.
No, they didn't. Think about the F-117 Nighthawk.
Classic black triangle.
Exactly. It relied on these flat, faceted surfaces to scatter radar waves. And the reason for that is actually pretty wild. The computers of the 1970s simply couldn't model continuous curves against electromagnetic radiation.
They didn't have the processing power to do the math for a smooth shape.
Right, so they made it blocky. But the F-35, it utilizes incredibly advanced computational fluid dynamics and radar cross-section modeling.
So it achieves a shape that maintains actual aerodynamic efficiency while aggressively deflecting radar energy away from the receiver.
And it's not just about deflecting any radar waves. The sources note that the F-35's geometry is highly, highly optimized against specific threats.
High-frequency fire control radars.
Yes, the ones operating in the X-band and Q-band.
Because those are the radars that actually guide a missile to a target. It's one thing to have an early warning radar vaguely know something is in the sky. It's another to get a weapons quality track.
Precisely. Defeating the fire control radar is what keeps the jet alive. But there's also the chemical and materials science aspect to consider here.
The radar absorbent material.
The RAM.
The RAM.
Yeah.
And our sources describe this not just as, a simple coat of paint.
It's a highly complex composite.
It is. It physically converts electromagnetic energy into thermal energy. The physics of that are they're quite remarkable.
How does it actually do that? Because turning a radar wave into heat sounds like magic.
It's structured at the microscopic level to literally trap the incoming electromagnetic wave.
So the wave goes in, and it can't bounce cleanly back out. Right. As the wave bounces around within the material itself, its energy is dissipated as heat.
Which severely degrades the return signal that actually makes it back to the enemy radar dish.
Exactly. So this combined approach, the geometric deflection plus the material absorption, it results in a radar cross-section that the sources compare to a metal golf ball.
A golf ball.
Depending on the angle of incidence, yes.
So you have a multi-ton fighter jet appearing on a radar screen as the size of a golf ball. If your enemy can't detect you, they simply can't target you.
That is the ultimate combat advantage. Historically, combat relied on visual and radar detection. Whoever saw the enemy first had this huge advantage.
But stealth turns that into an overwhelming advantage.
Overwhelming. Because enemy air defense systems might not even realize the aircraft is nearby until it is way too late.
But, and the sources heavily feature this debate, achieving that golf ball-sized radar cross-section requires some pretty significant design compromises.
It's one of the most debated aspects in the entire aviation community.
The internal weapon base.
Right. To maintain its stealth profile, the F-35 cannot just carry all its weapons externally on wing pylons.
Because if you stick a standard AIM-120 AMRAAM missile, plus its mounting pylon out in the airstream,
You create a massive radar reflector.
it essentially negates the low observability entirely.
It's a crucial trade-off. By enclosing the weapons internally, the F-35 has to sacrifice overall payload capacity,
Especially compared to a non-stealthy bomb truck.
like an F-15E Strike Eagle. Critics frequently point out this limitation. They'll say, look how many bombs the F-15 can carry compared to the F-35.
But the design philosophy justifies this by prioritizing survivability.
And that first look, first shot capability. Let's go back to that simulated strike scenario we established at the beginning.
Okay, flying into the teeth of the SAM rings.
Right. An F-15E might carry significantly more ordnance on paper, but it would have to violently fight its way through those SAM rings and enemy fighters.
It would likely require a massive strike package just to survive the trip to the target.
Exactly. But the F-35's internal carriage allows it to penetrate that exact same airspace autonomously, deliver a precision strike, and aggress completely before the threat systems can even establish a track.
So returning to our strike scenario, you are flying through that dark forest, but you are wearing night vision goggles while the adversary is just stumbling around blind.
That's a great analogy. The low observability ensures you can operate in environments that would frankly be fatal to fourth-generation fighters.
Okay, let's unpack this, because being difficult to detect is really only one half of the equation here.
Right.
If you are incredibly stealthy, but you lack situational awareness, you aren't a lethal predator. You are just hiding in the dark.
You're safe, but you're blind.
Exactly. Which brings us to a tiny golf ball-sized cross-section.
So the F-35 pilot has a luxury that rarely exists in combat.
The luxury of time.
They can patiently maneuver into the absolute optimal firing parameter. They open the internal bay doors, launch an AMRAAM, and close the doors.
Instantly restoring their full stealth profile.
The adversary's first indication that they are even under attack, their very first clue, might literally be their radar warning receiver alarming just seconds before the missile impacts.
Because the missile's own active seeker only turns on for the final terminal phase of the intercept.
It is a completely asymmetric application of force. The F-35 leverages its stealth to absolutely deny the enemy a firing solution while utilizing its sensors to guarantee its own.
The first shot almost always decides the outcome of the engagement.
And the F-35 is designed to ensure it always gets that first shot.
Now, up to this point, we've really analyzed the F-35 as an isolated platform, a single aircraft executing a strike.
Right, evaluating its individual capabilities.
But the sources are absolutely unanimous in stating that evaluating the F-35 as a standalone fighter misses the entire point of the program.
It's a fundamental misunderstanding of what the jet actually is. The most complex and arguably the most disruptive capability of the Lightning II is its role in network-centric warfare.
Hive mind.
This is where the paradigm shift we discussed at the very beginning, the shift from kinematics to information dominance, truly materializes.
Because the F-35 does not operate alone. It is engineered around a system called the Multifunction Advanced Data Link,
MADL.
MADL. Now, tactical data links aren't a new concept. Legacy fighters have used systems like Link 16 for years.
Right, to share target tracks and text messages between aircraft.
But if the F-35 is constantly broadcasting massive amounts of fused sensor data across the battle space, doesn't that radio frequency transmission just scream its location to enemy electronic warfare listening posts?
That's the logical question.
How does it stay networked and stay stealthy at the exact same time?
That is the exact vulnerability that MADL was designed to address. Because you're right, Link 16 is an omnidirectional broadcast,
It transmits in a full 360-degree bubble.
which makes it highly susceptible to detection and jamming by advanced enemy electronic support measures. It's essentially shouting your position in a dark room.
Anyone listening can hear exactly where the shout came from.
MADL, however, utilizes a phased array antenna system to create a tightly focused, highly directional, narrow beam of data.
Oh, so it's a laser pointer instead of light bulb.
Precisely. It is a low probability of intercept, low probability of detection communication system, LPILPD.
So how do they actually link up?
F-35s fly in a daisy chain formation, and they point these narrow beams directly at each other to share data.
Meaning a flight of 4 F-35s is not 4 individual jets sharing a radio channel?
No, they operate as a single distributed computing network.
A unified combat network. Let's apply that back to our strike scenario.
Yeah.
We have 4 F-35s pushing
A
into
surface fleet or a hidden coastal missile battery.
gathering all that targeting data.
Right. And without ever opening its weapon bays, without ever emitting a radar signature of its own, it can pass that exact targeting data via secure link to an Arleigh Burke-class destroyer.
A Navy ship positioned hundreds of miles away, well outside the threat zone.
Exactly. The destroyer can then launch a long-range SM-6 missile.
And the F-35 can provide mid-course guidance updates to that missile all the way to the target.
The F-35 serves as the eyes of the fleet, It enables assets to engage targets far, far beyond the horizon of their own organic sensors.
When you scale that capability across air, sea, and ground forces, the F-35 transitions completely from being a tactical strike fighter to a strategic information hub.
It literally lists the fog of war for the entire theater of operations.
It allows allied command and control elements to allocate resources, synchronize strikes, and maneuver forces with a level of fidelity and speed that adversaries simply cannot match.
If we connect this to the bigger picture, the overarching theme here is that we have definitively entered a new era of warfare.
Modern battles are no longer decided merely by firepower or the biggest missiles.
They are decided by information. Looking at the totality of what we've unpacked today, the geometric and material stealth, the AESA radar, the sensor fusion mitigating task saturation.
The DAS helmet eliminating physical blind spots, the MADIEL network creating this distributed battle space architecture.
It completely reframes how we define a fighter jet. The kinematic performance is almost secondary to its processing power.
Which is deeply ironic when you think about it. From the outside, to the untrained eye, the F-35 might look like just another standard fighter jet.
But inside, the literature heavily supports that it is one of the most sophisticated combat systems ever created.
Sometimes, the most powerful weapon is simply the one that sees everything before anyone else does. The historical metrics of warfare, the tonnage of bombs, the thickness of armor, they've been superseded by the speed and accuracy of the kill chain.
The side that can observe the environment, orient themselves to the threat, decide on a course of action, and act upon it the fastest. The OD loop is the side that survives.
And the F-35 is fundamentally an engine designed to accelerate the Allied O-Day loop while systematically collapsing the adversaries.
It is an incredibly complex piece of machinery. Evaluating its effectiveness requires looking way past the surface-level critiques of its payload or its turn rate.
You have to understand the informational architecture it brings to the fight. It's an airborne server rack that just happens to be supersonic and invisible to radar.
And examining that architecture, it really leaves us with a profound, almost philosophical question to ponder regarding the future of military aviation.
What happens to the pilot?
Exactly. If the platform is autonomously gathering multispectral data, correlating threat tracks, generating firing solutions, and managing the electronic attack profile, how much does this shift the traditional role of the human fighter pilot?
The cognitive role of the operator is fundamentally altered.
Are they still aviators in the traditional sense, focusing on stick and rudder skills or manual sensor manipulation?
Or are they transitioning into airborne battle managers?
Tacticians overseeing a massive automated intelligence network from inside the cockpit. As artificial intelligence and machine learning become further integrated into platforms like the F-35 and future next-generation air dominance programs, we have to evaluate where the line between the human operator and the autonomous system is drawn.
A shift from the dogfighter to the network administrator operating at 30,000 feet.
The F-35 is not just the current state of air combat, it is the bridge to a highly automated, information-centric future.
It's a profound operational shift that forces us to rethink decades of tactical doctrine. It's a lot to process, but understanding it is crucial to understanding modern warfare. Thank you for joining us on this deep dive into the source material. We've explored the complex engineering, the operational trade-offs, the strategic implications of the F-35 Lightning II. Until next time, keep analyzing the data, keep questioning the narrative, and we'll see you on the next one.